Hey, Jim.
Yeah.
Yeah, you can start.
Okay. Awesome. Making sure everybody can hear me. Let's go ahead and share that screen. All right. Are we good?
Yes.
Everybody hear me?
Yes. Take it
Awesome.
away.
Sorry for the delay. It is. I'm sure every speaker has come on and said this, but it is 6:30 in the morning, my time, and there's no one here. I'm here at Netflix, so I want to make sure the internet was good. And yeah, I don't have any jokes this early in the morning, but it is lonely. After this, I will show you the empty room that I'm talking to. But morning, afternoon there. As I was lovely introduced, thank you for that. My name is Jem. I work on Netflix at Netflix UI Engineering. And today I want to talk about something a little bit different. The last talks have been fairly technical, and they're all much better engineers than I am. But today I want to talk more about the process, about what engineering is, what it looks like, what is performance engineering to everybody else. Because to me, it's this idea that engineering is not just about butts and seats, as people say. It's about the people. At the core of every piece of code, every piece of software we write, it's the people that make all the difference. In fact, one of the mantras here at Netflix is that we believe in people and not ideas. So that's funny because most people don't think that. Most people think, oh, I have a good idea. Oh, I have a lot of money. Oh, I live in the best city because this city is the one with all the tech people and we're really smart and all these things. And so my idea is going to succeed, but that's not true at all. In fact, there's more people in this conference than there are in all of Netflix. There's more engineers at this conference than there are at Netflix. We have not that many engineers for our reach. And what I want to talk about today is, how do we do that? How is it that we're a relatively small company and we have such a global reach where Netflix is 34% of the internet's traffic? How is that possible? Today I want to talk about three ideas. Actually, I should say three problems. These were hard problems. These were million-dollar problems. I want to talk about the Light project. Talk to you about faster things. And I want to talk to you about Atticus. But mainly what I really want to talk about is the people behind the ideas. Because it's not enough for me to say, oh, we had this problem here at Netflix and then we solved it because we have a lot of engineers and all these things. But no, these problems were solved by just three engineers. Three individual people that thought a little bit differently about the problem. That challenged the status quo, that said, this is a hard problem, but you know what? I can solve it because that's who I am. But really, I want to talk about the difference between science and art, because software engineering is somewhere in between. And really, at the core of the talk, what I want to talk about is how things work. My name is Jem Young. I'm a senior software engineer here at Netflix. I say here, but you can't see anything. But I'm here at Netflix in California. And it's funny because people always say, what makes a senior software engineer? Senior. I know, senior software engineer is a bit ironic because my last name is Young. So even when I'm 70, I will probably still be a senior software engineer of some sort. Hopefully that joke lands. I can't hear if you're laughing. I'll just assume you're all laughing really, really heavily, and I'll pause for that. All right, okay, thank you. I can hear it now. It's really hard to tell a joke when there's no one around to laugh. And other than me and my cat and my fiance, there's no one really to laugh at all my jokes. So I appreciate that. But what is a senior software engineer? Well, a lot of people think, hey, senior software engineer, that means you probably write a lot of code. You probably write way more code than a junior engineer. Well, I try not to, if at all possible. And of course, you know, there's the rock star engineers that I've never met, but apparently all of the companies in the Bay Area are only hiring rock star engineers. But that's not the case at all. And in terms of senior software engineer, you don't define it by lines of code. In fact, I spend most of my day trying to write as little code as possible. That's true. I strive to be the laziest engineer at Netflix. I don't want to write any code if I can. Or if there's a bug fix or a feature to get built, I want to write the smallest amount of code as possible. And this seems a little weird, but that's the way it should be. In fact, one of my managers once told me a good quote. He told me that the more senior you are, the less code you write. And ideally, you would look for ways to avoid writing code because that's where the bugs come from. It's true. I have many war stories to tell you, maybe some other time. But I don't want to write any code if at all possible. Or I want to write the smallest amount of code because I can understand the changes. I can understand everything that's going on. It makes it easy to refactor in the future. So if I'm a senior software engineer, but you can't define my performance by the amount of code I write, then what is engineering performance? Let's not talk about engineering performance. Let's talk about the people behind it. Let's talk about human performance. Let's talk about what makes one person excel, what makes them a high performer. And to do that, I want to tell 3 stories. The first story is, it's about the Light Project. And of course, I can't talk about the Light Project without talking about the person behind it. So, meet Tony Edwards. Tony is a senior software engineer at Netflix. And Tony, he had a hard problem. You see, he worked on Netflix.com, the landing page. If you go to Netflix.com and you're not a member, you're going to see something like this. And to a lot of people, it's like, oh, it's a web page, right? It's a website. Anybody ever heard that? Oh, all you do is build websites? Anybody heard that? I've heard that like my whole life. And obviously, I would argue that it is one of the more difficult things you can do. And Tony understood this. Tony understood that if you're building a site that gets millions and millions of visitors, there's this complexity to it. Because at Netflix, we run a lot of A/B tests, and we've had tons and tons of engineering hours spent making Netflix.com as fast as possible. So when he was tasked with the project of making it faster, that's not that easy. You can't just look at some code and say, oh, I'm going to delete this code and boom, I'm done. No. So Tony was on this team, and I was part of this team as well. I had the honor to sit in and throw bad ideas, which got rejected. Some of them were okay. But we tried lots of different things to make Netflix.com faster. We tried different compression. We tried comparing Brotli versus gzip. Didn't do much for us. We tried different methods of compressing images. So instead of progressive JPEGs, we tried PNGs, SVGs. We tried lots of different, even obscure ways of compressing images, and it didn't do it either. Then I thought, how about I preload my JavaScript? So that way, nobody is waiting for the JavaScript to load. They come to the page, the JavaScript's already queued up. No, that didn't work either. So I probably should have mentioned this about Tony, but Tony is a car person. He loves his car. This is his car, Pegasus, a great car, Mustang 5.0. It's a good looking ride. But one thing that everybody knows about, or what you can say about car people, is that they know it's not the size of the engine. It's the weight of the car that matters far more. In fact, Colin Chapman, founder of Lotus Cars, he once famously said, simplify and then add lightness. So Tony used this innate ability, this love of cars, and he applied it to engineering. And he thought, I have this idea. Because when you're talking about speed of a page, you're talking about performance, it's not the loading time, it's not the rendering time, it's not the painting time, it's the scripting time. The scripting time is almost always going to be the slowest part of your page. So Tony said, well, if the scripting time is so slow, why don't we just take it out? And that's how he came up with the Light Project. Tony said, all right, everyone, let's take it all out. I said, take out what? He said, everything. I'm like, what do you mean everything? He said, everything. So let's take out every library we didn't need. Let's take out every bit of CSS we didn't need. Let's take out every bit of HTML we don't need. And let's strip it down to its bare minimum. You know, old school JavaScript, no frameworks. And it worked. It was this radical idea, but we believed in Tony, and it worked. It made Netflix.com 50% faster. 50%. We still use React on the server. We use React to render the page, but we don't send down the React library. We don't send down Lodash. We only send down the bare essentials, the bare minimum needed to execute that page in vanilla JavaScript. And it worked. An idea is so simple. So instead of adding more libraries and adding more complexity, we just took out the complexity. We made it as simple as possible. And the lesson we can learn from Tony and the Light projects and making Netflix.com 50% faster is it's the code that we don't write that often makes far more difference than the code that we do. And that's a hard lesson. That is a lesson that a senior software engineer would know, but other people, maybe less experienced, wouldn't think of that way. But that's something unique to Tony, and he had the latitude here to try something, this audacious experiment that worked, because we all believed in him. So that was Netflix.com. That runs on thousands of devices, but let's talk about something a little more obscure, something that you may have used, but people don't think about a lot. I want to talk about TVs, Netflix on TVs. But really what I want to talk about is the Faster Things project. Possibly one of the best names for any project out there. I don't know about you, but I'm a big fan of Stranger Things. It is delightful. A great show. Sorry, I will talk about Netflix shows all day. During the Q&A, just ask me, I have opinions on all of that. But part of what makes Netflix so good is the compelling reason that I can just turn on my TV and watch a movie or a TV show at any time. And most people don't know this, but TVs are really, really, really slow. In fact, my cell phone probably has 10 times the processing power of any TV. Yeah, we don't think about that TVs are slow. So we had this problem. TVs were a bit too slow. So that came upon this person. Meet Joey Cato. Joey is a senior software engineer at Netflix. And Joey had a hard problem, similar to Tony. See, the TVs, sometimes they were crashing. And I don't know if you've ever seen a TV crash. I've seen many of them. It's not pretty. And sorry, jumped ahead a bit, but I should have described Joey a bit more, because to talk about this project, I need to talk about the person behind it. And Joey is a hacker. And no, not the kind you see on the media as, someone wearing baklavas, hacking on is that like a 2000 year 2000 MacBook? I don't know. No, Joey's not that type of hacker. Joey is a tinkerer. In fact, Joey is so good, he's won Netflix Hack Day 4 times. 4 times. And I don't know if you know anything about the caliber and quality of engineers here at Netflix, but winning 4 times is a very difficult proposition. But that's the type of person Joey is. Joey likes to tinker. He likes to think outside the box. And he had this problem with the TVs. They're crashing because they're so slow. And when a TV crashes, it's really bad. In fact, what is even going on there? That's a crashed TV. That's a bad experience. When you're sitting down with your friends and family, your cat, you don't want this to happen. And there's a lot of these happening. On some of the lower end TVs, the TVs kept crashing. So someone said, "Hey, Joey, you look like you like a challenge." He said, "Yeah. We need to fix this. We need to fix this problem." So Joey thought about it. He thought, I've got this screen. We call it the plan selection screen. It's where if you're signing up for Netflix, you pick a screen and you join and you continue on into your payment method, etc. And it was nice and shiny and pretty, but Joey thought a little bit deeper. He thought about how things work at the core. He thought, to get a nice smooth transition from this screen to the next, and it's buttery smooth and it slides over and it looks good and everybody's happy and designers are happy. The only problem with this is, remember what I said earlier? TVs are really, really slow. In fact, when we talk about video memory, did you know an Xbox 360 only has 512, somewhere around there, of video memory? My phone has more than that. Your laptops have more than that. So not only do we need to run Netflix, we need to run the TV, we need to run all the apps, we need to run the Ethernet and wire. So we were running out of video memory and it was crashing. And Joey understood this. Joey's a UI engineer, but he understood that low level, deep down core of how TVs work. So Joey thought, hey, instead of rendering both screens at the same time and transitioning together to make it look nice and smooth, why don't we just render one screen and then render the other screen? A radical idea. And when he tested them out, it worked. It was so much faster and TVs crashed less. And you're probably thinking, hey, Netflix, we have pretty good design. No, we have beautiful designs. I'm not gonna lie, I'm really proud of our design team. And you think, well, if we're building something that's not as pretty, but it's faster, do you think designers are gonna go for it? Yeah, they do. Because we care about what's good for everybody around the world, not just being pretty. I mean, I care about being pretty. Look at this beard. Again, I assume you're laughing because I can't hear you, but or you're just admiring my beard, you're in awe. But it's interesting because when we talk to the design team and we approach this radical idea, like the site's not going to be as smooth and pretty and the animations aren't going to be as good, but we're going to crash less and we're going to have a better product all around. The designers, they're like, yeah, because that's the kind of culture we have. We want to empower engineers to make these decisions and then share them broadly. And we all agree that we want to do what's right for the end user all the time. And what we learned from Joey is you need that freedom to explore. You need that freedom to try radical ideas that no one ever thought. No one ever thought if we don't make these smooth screen transitions, it'll prevent video crashes. These ideas are so opposite of each other, but that's what makes a good engineer, is they take their experience, just like Tony did with his car, and Joey did with his ability to tinker and hack and learn deeper. That's what makes good engineers. So that was the Faster Things projects. And the Light project and the Faster Things project were impressive. They really changed how we thought about UI. They changed how we thought about the problems that we have to solve every day. But now I'm talking about something a little bit different. I want to talk about Atticus, the Atticus project. And again, I cannot talk about any good project without talking about the engineers behind it. Meet Aishwarya Rajmani. Aishwarya is a senior software engineer here at Netflix. And Aishwarya had a problem, as all engineers do. You see, Aishwarya worked in this complex, massive node application that we know as Shakti. And Shakti it's the gateway to pretty much the rest of Netflix. If you use Netflix on a mobile device or a web browser or anything like that, you're going through Shakti, which is a really complex node application. The thing is, Shakti is just one part of this massive, massive ecosystem that we know as Netflix. This big system of complex microservices and interconnected dependencies and lots of names. And I don't even know what most of these are, honestly. I know what Shakti is. That's what I work in. But Shakti was dependent on all these services to serve out the right content. And one of Aishwarya's job was to make sure that we don't break Shakti. So she had to oversee a lot of tests. A simple test would be something like this. We call it sign-up payment selection, yes, for Spain. And it's just moving from one screen to the next, just making sure the experience isn't broken, because we have 30 some odd engineers on our team constantly pushing, constantly breaking things, mostly me. And Aishwarya's job is to make sure that the site didn't break. The problem was, not in production, but in tests, the site was breaking. The tests were failing. And the problem when you get that much noise is that people stop watching them. You stop ignoring tests. Why have a test if it's going to be flaky half the time? We did a little better, but at one point, our APIs were so unstable that only 88% of tests passed. That means if I ran 100 tests, 12 of those tests would fail, not because the test itself failed or the code failed, but because one of those many, many downstream dependencies failed. So that's not good. We want people to write tests. We want people to believe that when their test fails, it's because the code, but people stop looking at them because we had so many failures. And it's not just one test. There are thousands of tests. At any given time, there are thousands and thousands and thousands of integration tests running constantly on Netflix. Someone once told me that in a day, we probably run a couple million tests across all our devices. So imagine if instead of 12 out of 100 of those tests failing because of downstream dependencies, imagine if it was thousands. You'd stop looking at tests at that point. You'd say, well, I've spent an hour looking at the test and it wasn't even my problem. It was some other service that failed. That's not good. What we needed was some sort of foolish engineer to take on a project like this. Hi, that's me, foolish engineer. They said, Jem, we have this hard problem. Do you think you can solve it for us? I'm like, yeah, of course I can. See, little did I know that 4 or 5 engineers before me had tried to solve this and they couldn't. Nobody told me that. Nobody said, yeah, Jem, actually, we've been trying to solve this for years and we couldn't do it. No, it wouldn't matter. I'd still go into it. So I went into it thinking, how can I tame this complexity? What would you do? I probably did the same thing as you. I started with mocking. Mocking is this idea that you take an API endpoint and you say, hey, I know what it's going to return, this basic structure. How about I just mock all of that out? And then I just keep that statically and it'll work. It's a good idea. Doesn't work. What happens when many of those downstream services change, which they do all the time? They change every single day. Well, now I have thousands of these JSON payloads that are now out of date, so I need to keep them back up to date. Because remember, I'm not the only engineer here. There's a lot of engineers and they're constantly pushing all the time. They're pushing code. We're trying to make it better all the time. And sometimes things break. Remember what we said about code and bugs? It's true here too. It's true everywhere. So mocking wasn't going to work. What do we do now? Sorry, I lost you here. There we go. So mocking won't work. How about record replay? Record replay is this idea where we take this, whoops, sorry, I am getting a message and I don't know what it says until I switch out. Apologies for this.
It's about the time.
Okay, I will speed through this then.
Thank you.
All right, so record replay is the idea of recording an API request and playing it back over time. That wasn't going to work because there are things in every API request that change, like a timestamp. And not every single API request, even though it looks identical, is going to return the same thing. So record replay wasn't going to work. So what do we do? I went like I do. I talked to my manager, Mr. Ryan Burgess. I said, Ryan, I'm stuck. I can't solve this problem. And Ryan said, it's okay because we don't hire you to write code. We hire you to solve problems. And if you can't solve this problem, that's okay because you learned something. So I kept pushing. I pushed myself to the edge. You know the edge where you can only think about this problem? That's all you can think about? You're on a date. That's all you can think about, this problem? That's where I was. I was up late at night trying to solve this problem. And eventually I came upon it because I knew that Ryan and my team believed in me. I took this API, I cut out the things that changed, I split that into a key, then I had the test name, the method, the request count, and the SHA-1 hash. And that brought our testability from 88% to 99%. Problem solved. And not only that, it was 33% faster. All the tests run 33% faster, serving us millions of dollars in server costs. That's Atticus. That's my project. That's hours and hours of work to try to solve this hard problem. Because what we can take away from all these is it's the code we don't write. It's having freedom to explore. And it's this idea that we believe in people, not ideas. And that's what engineering performance is. And that's how things work. What happens if you empower your entire team? What can you build then? Thank you.
Thank you. Thank you, Jem. Thank you for that fantastic presentation. Any questions? Okay, we entertain only one question because our time is fast spent. Any question? All right, one question.
Hello, Jem.
Hi.
Are you okay if I call you Kratos?
Sure. I mean, maybe I'd rather be like Thanos or something, but you know, Kratos works too.
Good. I like your beers though. A bit lesser than mine. Yeah, my question is this. Is it possible, to have a very great UI without sacrificing performance?
Oh, absolutely. The thing is, it takes discipline. Don't let anybody say any one library is going to solve your problem, or if you use functional programming, or if you use this, you use that. That's not going to solve your problem. The way to build great UI is to think about it as you're building this thing that's going to run on tons of devices, low end and high end. I can build great UI that doesn't sacrifice performance. There's a cost to that. It's going to take a bit more time to build. So what you really need to balance is that performance versus the quality of the UI. And somewhere in the middle is where we put good software engineers.
All right, thank you. Thank you, Jem. Thank you for the presentation. Thank you for waking up so early.
Thank you for listening. Wait, can I do this one thing? Can you see me? Wait, I'm going down the stairs.
All right.
Okay, I'm done. Thank you, everyone.